Hello everyone. In today's class, let me start with the strength of material subject, and the first concept is simple stresses and strain. So why is this strength of material required? The main aim of strength of material is to access various properties of material and use them according to the requirement. There are various properties of a material like strength, stiffness, etc. So there are assumptions. Assumptions are material is solid and continuous, no cracks in the material and no voids in the material. Material are homogeneous isotropic. Self weight of the material is neglected. Superposition principle is valid. And there are limitations also. So the first concept, first definition is stress. Stress is nothing but the resisting force per unit area is stress. The external force per unit area is pressure. Stress is equal to force per unit area. So SI unit is it can be Newton per meter square or Newton per mm square. Stress are divided into two types: direct stress and indirect stress. This direct stress is again divided into normal stress and shear stress. Indirect stress is also divided into two types: normal stress and shear stress. Talking about the next concept called strain. Strain is nothing but there are two types of strain: normal strain, shear strain. Normal strain is nothing but change in dimension to the original dimension, change in length to original length, and shear strain is nothing but the angular change between any two mutually perpendicular planes in radians, and this is unitless dimensions. And there is a volumetric strain, change in volume by original volume. Next concept is material properties. And first material properties is elasticity. So in this elasticity, so what is elasticity? Is a material which regain its original size and shape on removal of load. Next is plasticity. A material undergoes permanent deformation at constant loading in is called as plasticity. Ductility is nothing but the property by which the material can be made into thin wire. Malleability is the property by which the material is made into thin sheets. Brittle is nothing but it fails suddenly. Such a material is called as brittle. Are very much strong in compression, moderate in shear, weak in tension. Creep. The permanent deformation occurs at a constant or sustained loading over a long period of time. Toughness. Resistance of a material against sudden or impact loading. Fatigue. Reduction in strength due to repeated loading is called as a fatigue. Next, stress strain curve is most important topic. It's a graph drawn between stress and strain. Point A represents the proportionality limit where stress is linearly proportional to strain. B is called as an elastic limit. Up to B, material is elastic, which can regain back its original shape and size. C is called as upper yield point, D is called as a lower yield point, E is called as a plastic zone, and F is called as an ultimate stress, and G is called as a failure point. This is about the stress strain curve and factor of safety for a ductile material and a brittle material. So the definition for a ductile materials is yield stress by working stress. Brittle material is ultimate stress by working stress. Next topic is elastic constants. So there are elastic constants. Young's modulus of elasticity. Young's modulus of elasticity is defined as a ratio of stress by strain within elastic limit, and GCN is a representation for modulus of rigidity. Modulus of rigidity is nothing but shear stress to shear strain. K is bulk modulus. Bulk modulus is nothing but the normal stress to volumetric strain. And Poisson's ratio mu gamma 1 by m, it's represented by this, and the ratio of lateral strain to longitudinal strain. Relationship between E, G, K, mu is E is equal to 2G into 1 plus mu, E is equal to 3K into 1 minus 2 mu. So when you equate these two, you get mu formula 3K minus 2G divided by 6K plus 2G. When you substitute mu in any one of the equation, E is equal to 9 kg divided by 3K plus G. I'm talking about the linear deformation, linear and volumetric changes of bodies. A prismatic bar is subjected to axial load, there will be change in length. So stress is equal to load by area. Strain is equal to change in length by original length. So Young's modulus of elasticity is equal to stress by strain. Delta L, when substitute stress P by A and strain delta L by L, so we will get PL by AE. Next, due to self-weight of the body, one end of the bar is fixed, and due to self-weight W, L is the length, so delta L is equals to WL by 2AE. These are the basic concepts of strength of materials in simple stresses and strain. And in the next class, I'll be discussing about the question paper questions solved on this concept. Thank you.